Let's talk about vector equation of lines. You need to have some basic knowledge on vectors and also make sure you understand the formulas and the rules. Don't just memorize them. If you know 2 points on a line, you can find the vector equation for it. So let's say you know the 2 point A and B. So let R0 be the vector OA. So now you need to work out the direction vector V. The direction vector is just vector AB. So in this case, your vector equation would be given by OA plus T times the vector AB. T is like a parameter which gives you the length of that vector. Alright, so in this example here, you are given this point. So let that point be the point A. And you know that this line is perpendicular to another vector. And also this line is parallel to the xy plane. So these are the steps. So firstly, you write down your vector R0 and you don't know the vector V, which is the direction vector. So let the vector V be AI plus BJ plus CK for now. Since you know that this line is perpendicular to this vector, that means the direction vector V must be perpendicular to it as well. So what you can do is you can take vector V dot with that vector and make it equal to 0. So now you end up with the equation negative 3A plus B is equal to 0. That means B is negative 3A. Note that because this line is parallel to the xy plane, so you can let C to be 0. Now coming back to the relationship between B and A, you know that B is equal to negative 3A, so you can pick a value for A, for example 1. Okay, so if you let A to be 1, then B is negative 3. So now you can substitute A, B, and C into the vector V. So this one is your vector equation of this line. So next we are going to talk about the Cartesian equation of that line. So now that you got the vector equation, the Cartesian equation just means that basically, so you look at the three separate components, the x, the y, and the z. So in this case here, the x would just be x1 plus at. So you rearrange that and then you make t the subject. So t would be x minus x1 over a. Similarly, y would be y1 plus bt. Rearrange that, you will get t is equal y minus y1 over b. And lastly, so the z components would be z1 plus zt. Rearrange that again. So now you got t is equal to z minus z1 over c. So this one is called the Cartesian equation. Alright, let's look at this example. So now you are given the Cartesian equation and you are asked to work out the vector equation. So what you need to do is you rearrange to make x, y, and z the function of t. So like these ones here. And then with the vector equation, so because you know that your x component is this, is substitute into the I. And then your y is equal to 3 plus 5t. So substitute that into here. And then lastly, your z is negative 2t. So substitute into the k components. So this one is the vector equation. Intersection between two lines I think it's quite straightforward and intuitive here. So let's say you got two vector equation given to you and you want to know at what point they intersect. So what you do is, so for R1 for example here, so you would combine the I components, the J components, and the K components. So that's why you end up with this one here. So 3 plus Si and negative 1 plus 2Sj and then 7 plus Sk. Similarly, for R2, so you would rip the components into I, J, and K. So now, to work out where they intersect, so you let the I component of R1 to be equal I component of R2 to get the first equation. And then you do the same for the J components and the K component as well. So now, if you solve the first two equations, you will work out a value for T and S. You don't just stop there because you got the third equation as well. So once you have got T and S, you have to substitute this back into the third equation to make sure that it works. In this case, it does. So last step, so to work out the point of intersection, if you choose R1, then you would substitute the S value into here to get that point. If you choose R2, you would substitute T value into here. It doesn't matter which one you choose. So that's how you work out the intersection between two lines. So perpendicular distance between a point and a line. There is a formula for it, but it's a bit complicated. So I thought, you use knowledge of dot product to work it out. It just makes much more sense. All right, so we are given the Cartesian equation, and we want to work out the perpendicular distance from that line and this point here. So if you can look at the diagram here, so that's the point Q. So if you let point P be a point on the line such that the line PQ is perpendicular to that line here. So from this Cartesian equation, you can work out the parametric equation. Parametric equation, this means you make x, y, and z the subject, so that depends on the t. So for example here, t is equal to x plus 4 over 2. So rearrange that, you will get x equal to t minus 4. And you apply the same method for the y and the z. Alright, so once you have got x, y, z, you can form the vector equation. Now, the point P. So P could be anywhere on that line. So in the general term, because this one is your vector equation, so the point P would just be negative 4 plus 2t, comma 3 plus 5t, comma negative 2t. Okay? So next step, you want to work out a vector PQ because you have the point P and the point Q. Alright, so that's a vector PQ. And we also know that the direction vector of that line is given by that, which is V in this case. Okay? Because PQ is perpendicular to the line, it must be perpendicular to V as well, because V is the direction vector of that line. So you want to take dot product between PQ and V and make that equal to 0. Okay, so now you end up with an equation in terms of T. So now you solve for t, okay? So once you got t, you substitute that back into the vector PQ, okay? So what I mean is that when t is 2 over 11, the line PQ is perpendicular to the line that you're looking at. All right, so that's a vector PQ, and you can work out the distance PQ by taking the magnitude of it. All right, next, so we are looking at the perpendicular distance between two lines this time, okay? So keep in mind that each line is defined by a point and a direction vector like that. So I think this formula here is useful, okay? So let's try to understand that. So A is a point on line 1, B is a point on line 2. So what you want to do is you want to find a vector joining these 2 points. So that would be vector AB, and hat is the unit normal vector, so which is perpendicular to both U and V. Okay, so let's have a look at this example. So to work out the vector AB, so basically you take this vector here minus this vector. Okay, so this one is your vector AB. To work out n hats, so you would take U, and then you take the cross product between U and V. So that's what's happening here. I will not go through the mathematics here. So that's how you work out the shortest distance between these two lines.